This is part 2 of a video series we're doing on several new products for the optical microscope. The first one I'd like to talk about is a retrofit to make your microscope have very homogeneous and even illumination. This is achieved using an LED illuminator made in America that simply connects to an existing optical condenser lens from a microscope. Typically one would have a Nikon, Olympus, Zeiss, Leica, older lights, Modic microscopes. They all will have external lamp ports with condenser lenses built in, or they may have older lamp housings that at one time had a 12 volt 100 watt halogen lamp. The RetroDiode Illuminator is made on a 3D printer for the fixture. The LEDs are a matrix of 9 very bright white LEDs that do not change color temperature as you reduce intensity, which is very useful. And as we mentioned, you get a very even, homogeneous illumination beam, unlike halogen lamps that have a hot spot. The control unit is a high frequency electronic control unit, on-off switch. You can adjust the intensity with a rheostat, and this works out beautifully for most photomicroscopy involving today's modern digital SLR cameras. The next thing I want to speak to you about today is a follow-on to the Infinity Photo Optical USA-made INFOCUS, which, as you may remember, is simply an adapter that fits onto an existing infinity-corrected microscope with infinity-corrected objectives. Whether they be for metallurgy or life science, it doesn't really matter. The INFOCUS actually replaces the trinocular tube, eyepieces, and optical coupler that you would normally use in the photo port to connect your camera. The unique thing about the INFOCUS is that we have an adjustment ring that allows us to very carefully adjust for the best resolution, and this ring has optical connectivity that compensates for spherical aberration corrections. Spherical aberration is a phenomenon that is caused by cover slips, in the case of biological slides, cover slips that are too thick or too thin for what the manufacturer has corrected the objective for. Typically, today's modern microscope objectives are corrected for a 0.17 millimeter thick cover slip. This translates to being called a number 1.5 cover slip. But the problem is the mounting media that goes between the sample and the bottom of the cover slip, that thickness or thinness of the mounting media can also cause spherical aberration. So the purpose of this INFOCUS and the patented lens groups that are in here is having the ability to turn a simple ring, look until the focus looks best to you, and then we can go and use these medium to high dry objectives with any thickness cover slip or any thickness mounting media that we choose. For demonstration purposes, I've got an older Nikon digital camera. It's a small format camera with a C mount added to the INFOCUS, but of course we can also put onto the INFOCUS a 2x optical coupler. We would remove the small format camera, remove the small format mounting ring, and now when we put on the 2x optic, we're going to have full frame illumination for up to full frame 35mm sensor cameras. This translates to being the largest format sensor that is typically available is 24 by 36 millimeters, which is the same size as a piece of 35mm film. The diagonal of such a sensor is 43 millimeters. Now that's many times larger than what you would find in a 1/3 inch or 1/2 inch small format camera sensor, which may have a diagonal of 8 millimeters, maybe 12 millimeters, depending on whether you get the 1/2 inch sensor or the 2/3 inch. So you get much more field of view with the large format sensors, and now you can put your DSLR camera directly onto the INFOCUS and do all of your photomicroscopy via live view off of your computer screen. It is conceivable to put a double beam splitter diverter box on this module so that you could have simultaneously the small format camera simultaneously with the large format camera. But most of these DSLR cameras today that have the live view feature also have HD streaming capabilities, and this opens up a whole new ball game to use the microscope as not only an educational tool in real time, but it allows you to use the large format cameras for the ultimate in resolution and field of view. So if we remove the INFOCUS module and the 2x lens, I want to show you a brand new component that looks similar to the INFOCUS, and it's called the Infinitube Ultima. We use the same adapter ring to mount it to the various support stands, and here's the Ultima unit. It's a group of optical components in here that are designed for any of the nozzle microscope makes, and there's a movable lens group here that's controlled by this sliding lever here with lock screw that allows us to parfocalize our low magnification objective with our high magnification objective. The interesting thing about this piece, as with the INFOCUS, full frame 35mm framing and no vignetting capabilities. So we now put this on in place of the trinocular tube, all precision fit, made in America, and we can now put on the 2x component, mount our DSLR camera, you can get this oriented so you can see what's going on. Notice I have a USB wire coming out of the camera going directly via USB 2 directly into my laptop. We turn the camera on, and now we can go in and take a look at things directly from the, in this case, a Canon live view feature. They all have this same basic feature. And now we can take a look, and the first thing you see immediately is the fact that we have a much larger field of view with this camera that has an APS-C sensor as compared to the small format camera. So you get a feel for how we can focus this. This is a good example of where we would want to use some Z-stacking software. So that's a whole different can of worms for Z-stacking. You can motorize the fine focus, or you can just use it manually using software such as Zerine Stacker or Helicon Focus. So Infinitube Ultima, INFOCUS to correct for spherical aberration, and full frame 35mm size format sensors, LED illumination to retrofit for even homogeneous lighting, modern digital cameras that cost under $1,000 with live view to go directly into your laptop. You do all your photo composition directly from the monitor and create your photography that way. Put it directly onto your hard drive, external media, record in HD, view in HD on big screen monitors or DLP projectors. This is the modern way to adapt old microscopes, and I appreciate your attention and hope you enjoyed listening to what we have to say about some of these new accessories. Have a good day. Thank you.